Hello everyone, today we start the circular motion. What is the circular motion actually? Before starting the circular motion, we have an idea about the circle. Because everyone knows about the circular. Someone says there is a circular motion, then it means everyone understands there is a motion in the circle. It doesn't mean for circular motion, every time the motion will be in the circle. Circular motion in circle is only the special case. Circular motion can be like this. Suppose that a car is going on the straight line track and observer is here. Observer is observing this car. So to observe this car, observer has to turn his face to watch this car continuously like this. Suppose that car is here, angle is 0 degree. Suppose that car is here, angle is 30 degree. Suppose that car is here, angle is 60 degree. So like this, if car is moving on this track, angle is continuously changing. So for this observer, car is in circular motion. It doesn't mean for the circular motion, only the motion is in circle. Only circle is the special case of the circular motion. Before starting the circular motion, we have to discuss some terminology of the circular motion, like angular displacement, second one is the angular velocity, third one is the angular acceleration. In kinematics, you heard about the displacement. But here we study the angular displacement. Why we study the angular displacement circular motion? Because if we are moving in the circle, suppose that we take a special case, we are moving in the circle. Center is here and we are moving from this point. Suppose that we are at here, then the angle will be 0 degree. Suppose that we are here, the angle is at 10 degrees. Suppose that we are here, the angle is 20 degree. Continuously angle is changing, but if we focus on this point and this point and this point is, it has the displacement this one, this point it has the displacement this one, this point has the displacement this one. Every point has a different displacement, but if we say what angle covered by this point, what angle covered by this point, what angle covered by this point, from going point from A to B, this point covered angle of 10 degree for going from A to B, but displacement of every point on this line is different, but angle covered by the every point is same. So what is the conclusion? What is same for all the points? Angle covered is same for all the points. It means we have to discuss the angular displacement, because if any object is going from this point to this point in a straight line motion, then suppose that there are 4 points on the object. Suppose that there are 4 points on the object and object is going from here to here. So every point in this object has the same displacement. So in kinematics we were discussing about the displacement, but here we are seeing that displacement of every point is not same, but angle covered by the every point is same, but displacement is not same. So what is same for all the points? That will be the terminology of that motion, because here angle covered by the every point is same. So we are here to discuss the angular displacement, not displacement, because every point has a different displacement, but angular displacement of every point is same. Now, according to the kinematics, displacement covered by the object in 1 second is known as velocity. Similarly here, displacement covered by the object, angular displacement covered by the object in 1 second is known as angular velocity. Suppose that an object is doing a uniform circular motion, then angle covered by the object in every second will be same. Then we can say, suppose that object covers 10 degree angle in every second, then we can say 10 degree per second. So we are because SI unit of angle is radian, so we have the unit of angular velocity is radian per second. Similarly to the velocity unit has meter per second. In 1 second, what is displacement covered is known as velocity. In 1 second, what is angle covered is known as angular velocity. Similarly to the kinematics, displacement is a vector quantity. Here angular displacement is also a vector quantity, but you will see how. Object is going from here to here. It means object is going on this circular arc, then vector should be curly. But we studied earlier that there is no curly vector, because vector is represented by a line having an head and tail. Head represent the direction of the vector. So how we represent the direction of angular displacement? So what will be the direction of angular displacement? Curl your fingers in the direction of motion. Curl your fingers in the direction of motion. The direction of thumb will give you the direction of angular displacement. Similarly, that will be a direction of angular velocity. Suppose that object is moving like this. Then what will be the direction of angular displacement? Out of the plane. What will be the direction of angular velocity? Out of the plane. If object is moving like this on the circular track, then what will be the direction of angular displacement? What will be the direction of angular displacement? Inside the plane. What will be the direction of angular velocity? Inside the plane. Direction of angular velocity, direction of angular acceleration, direction of angular displacement is same. It is always same. Now we are here to discuss the angular displacement, because angle is represented by theta. So angular displacement has the notation theta. Theta has the formula arc length divided by radius. Arc length divided by radius. Arc length is also has a unit meter. Radius has also unit meter. So meter cancel out each other. So theta is a unitless. Theta is a dimensionless, because L upon L will cancel each other. So L power 0. Theta is the dimensionless, but theta is not the unitless. Theta has a unit radian. You also studied in the chapter units and dimension. It is a supplementary physical quantity. Plane angle and solid angle. Radian is a SI unit of the plane angle. So what is the unit of angular displacement? Is radian. What is it? Angle covered by the object. What is the angle covered by the object? Angular velocity. What is the angular velocity? Angular velocity is the angle covered by the object in every second. Now, suppose that if I say there is a circle, an object is moving on a circle from this point to this point and covered 120 degree angle, then what will be the angular displacement of the object if the radius is 2 meter? Then we have to change it 120 degree into radian, because we know 180 degree is equal to pi radian. 1 degree is equal to pi upon 180 radian. So 120 degree is equal to pi upon 180 into 120. 0 will cancel each other. 6 2 are 12, 6 3 are 18, 2 pi by 3. Then what we say? We did not say 120 degree is the angular displacement. We say 2 pi by 3 will be the angular displacement, and sense of rotation is anti-clockwise, so we have to curl our finger in the anti-clockwise direction, then the direction of thumb will give you the direction of angular displacement. So we say object has a 2 pi by 3 angular displacement out of the plane. Now, angular velocity. Angular velocity, we have to discuss the angular velocity. We will take an example. We have to keep in mind that circular motion does not mean motion in the circle. First of all, we will take the example of straight line motion as a circular motion. Circular motion. Suppose that what is the angular velocity? Angular velocity. It is denoted by omega. This is also a vector quantity. And it has a unit radian per second. What is the velocity actually? Rate of change of displacement. Then what is the angular velocity? Angular velocity will be the rate of change of angular displacement. It is the instantaneous angular velocity. As in kinematics, V instantaneous was ds by dt, but omega average angular velocity will be what? Change in angle divided by change in time, appreciable change in angle in the appreciable change in time. Agar time, if there is a large change in time, large change in angle, then we have to calculate the average angular velocity. Now, suppose that we take an example. Suppose that there is a circular motion and object is moving from here and going from here to this point, covers an angle of 120 degree. Then what is the angular displacement? As I discussed earlier, 2 pi by 3 out of the plane. 2 pi by 3 radian out of the plane. But if I say what is the angular, if object takes 5 seconds to go from here to here, if object takes 5 seconds to go from here to here, means time taken is 5 seconds. Yeah, you can say change in time is 5 seconds. Then what is the average angular velocity? Average angular velocity will be change in angle is what? From here to here, change in angle is 2 pi by 3 divided by time taken, means 2 pi by 15 radian per second. This will be the average angular velocity. This will be the average angular velocity. Now, suppose that omega is given as a function of time, because suppose that I said theta is changing with time, like this, 3t square plus 5t plus 6. I said find angular velocity at t equals to 2 seconds. Then what will be the procedure? Now here I asked find angular velocity at t equal to, I asked angular velocity at a particular instant of time. It means I am talking about the instantaneous angular velocity. What do you mean by instantaneous? Instantaneous means angular velocity at a particular instant of time. Angular velocity at a particular instant of time, it means theta is omega is d theta by dt. It means we have to differentiate this theta with respect to time. Now it will be 6t plus 5. So we have to calculate omega at t is equal to 2 seconds. It means put t at the place of t2 plus 5. It means 12 plus 17 radian per second. It means angular velocity at time t is equal to 2 seconds will be 17 radian per second. Now we take another example. suppose that a car is moving on this track and observer is here. Suppose that car has a constant velocity. Now we have to discuss one more point. Theta is what? Arc length divided by time taken. Suppose that we are moving in the circle, then we have the actually speed. Suppose that we are moving in the circle with constant speed, then what is, we have the speed because our odometer shows the speed. Suppose that a car is moving on the circular track, then odometer of the car will show you the speed of the car. Suppose that car is moving with uniform velocity, uniform speed, car is moving on the circular track with uniform speed, then theta will be the arc length divided by time taken. Sorry, arc length divided by radius. Then omega is what? D theta by dt. It means d of arc length divided by radius divided by dt. On changing the time, arc length will change but radius will not change. It means we can take radius outside. 1 upon radius is equal to d of arc length divided by dt. d of arc length is what? Distance covered. Then we can say 1 upon r ds upon dt. ds upon dt shows the speed. So omega is equals to v upon r. Omega is equals to v upon r. Now we have बंद कर दो सर.
ये बेटा लाइट तो
बंद कर दो सर. कोई बात नहीं, इतना सर.